Right now, if I were to ask you what's the vertex with this equation, we wouldn't know that. But if we could put it into vertex form, now we can identify our vertex, the axis of symmetry, okay, all that good stuff, okay? So take a minute, see if we recall this. Remember what we were doing yesterday. If you feel like you still need to draw in a little area model, I think a lot of us understand it with that, so that's not a bad thing. Take a minute, draw it in. Either way, see what we come up with. See what we think. I'll give you a minute. Do you see they all have hands right now? They can raise their hand on the screen.
Yeah. I think Mr. Ball was trying that yesterday though. Unless they updated, the hand doesn't light up.
Oh, really?
Just in the bottom left corner of your screen, their name will pop up and then disappear.
Oh, just right away. Well,
yeah.
Okay.
So I don't know if it's...
Good intentions.
Yeah, I think they need to update it a little more.
All right.
Unless it was just we were having issues with it yesterday, but because we thought like the hand would change color or something like on their picture would illuminate it, but it just popped up a little.
Got it.
Yeah. I can raise my hand, see if it does anything.
Yeah. I didn't see anything. Heard something.
Yeah. So like not like in the lower left hand corner of the feed, like my name would pop up and then it goes away pretty quickly.
I'd have to see it right away.
Yeah. So I think they're working on it, but with all these hands, I thought it's like the hand would turn like yellow or green or something.
Right.
All it would alert you.
Okay. All right, let's see where we're at. I went ahead and drew this in just so we can again understand sort of why we're doing the way we're doing it without the area model. So what I've been telling you to do is take this x squared minus the 20x, and we've been ignoring the 36 initially because it's pretty rare that when we take the x squared and put it here, and we take our negative 20 and put half of them here and half of them here, that it works out perfectly to give you the constant in the back. All right, so in this case, what we would do is plus, we're gonna try to make a perfect square out of this right here. So we're gonna ignore that 36 because it's rarely the perfect number that we want. And we see that right away up here. When I actually fill in what would make this a perfect square, it would be a 100. Well, we don't have a 100, so that's how we know we've got to adjust a little bit. But that's what we would fill in right here to make this a perfect square. So this guy right here is an equation or an expression for this figure that I have drawn in up here. So when we now simplify this, so it's in perfect square form, so we can identify the vertex, what we have is an x minus 10 here, we have an x minus a 10 here, we multiply those together, we're just writing that as a quantity squared. What we need is 36, what this currently has is 100. So the way that we can adjust to get this number on the back side is we just take the number that we're actually getting from this right now, which is a 100, we subtract it away from the number that was already there. So this should have been a negative 64. Okay. All right. A few people nodding heads yes, looking confident. Okay. Now that's we've been doing for that one for like a week. All right. When we just have a 1 in front of this, that we've been doing for a while. What we now try to do, which is definitely harder, is what happens when we have a 2 in front of this. But it's the same idea where in terms of the way we're going to do, let me make this bigger for you, Andrew. Small. Where we're going to ignore the negative 30, because probably not going to be the nice number that we would want it to be to complete our square. And we'll deal with him at the end. Our issue, like I just mentioned, we need this to be a 1. Right now it's not a 1, so to make it a 1, we're going to get rid of that 2. We're going to pull that 2 out. So if I pull the 2 out, I don't know, I'm not flipping this over. So if I pull that 2 out, we're left with an x squared. And then we should have plus, we also have to pull the 2 out from this 12. So what we've talked about is we're undistributing. So if I now do 2 times x squared, it better give me the 2x squared. what should be left over in that next spot is 2 times a what is going to give me that 12. That would have to be 6x. And then still ignoring our 30. From there, largely just do what we did at the top of the page, or the previous problem. Make this a perfect square. So what would we put into that parentheses? If I had x squared plus 6x, we would then do plus, and hopefully we all get a 9 there. We would have put 3 in each corner. That means we have a 3 times a 3. That's going to give us our 9. Then what we have to do then is on this back end here, we've got to subtract away what we just added to our problem. So yeah, we just added a 9, but it's not just one 9. If we drew this out with all these little rectangles, wouldn't there be 2 of those? So it's not just a 9, it's an 18. So we would need to subtract 18 from the back. And the way we can get that 18 without having to draw it in is just understanding I have a 2 times a 9. It's not just a 9. It was the 9 getting multiplied by a 2. So that's really an 18. From there, we can do vertex form as 2 times the x plus a 3 squared. And then minus a 48. Okay, real quick, I lied. I'm going to turn this over to you, give you 2, 3, 4 minutes, do number 12 and see if we can get through one, because the next one we're going to do is a negative. At some point we need to get to those. So now see if we can do number 12. Oh, yeah, there were 3 others. Okay, a lot of people looking up, so that means hopefully they're done with the right answer. Okay, let's see where we are at. I usually start by knowing that we're going to make a perfect square trinomial with the first 2 terms, and then deal with the constant at the end. We want this number to be a 1. It's not, so we're going to pull that number out in front, leaving us with an x squared. What would have to be our next term? So if I did that times 2 to get a 16, this would have to be an 8x. Okay. Now from there, you're really just focusing in on right here. We want to make this a perfect square trinomial, something we've done plenty of. So what we should be adding here, you would take that 8, you would have split that evenly to get 4, and then we would have a 4 and a 4 multiplied together to give us a 16. So notice how we just added 16, but we have 2 of those. We have 2 16s that we would have had if we were to draw out all of those squares. So what that really is 32. That then is how we can adjust by subtracting 32 from the backside. So we now get 2 of these x plus 4s multiplied by each other, and then minus a 22. All right, Cam got it. That's good. Other people get that? Are we getting there? Okay, good. Very good. Slowly but surely. All right, so now, what I've been avoiding, not that this is terribly much more difficult, but definitely a little different. Let's find a negative. We're just going to continue in the homework. We'll get you through the homework a little bit. I want to do 17 next. And what you'll notice is, here's our square term. We don't have a 1 in front of it. We have a negative 2. It's going to start out the exact same. It's not anything terribly different in terms of your steps. You're still going to go ahead, try to make a perfect square out of the first two terms. And then that plus 5, we're going to ignore. We want this to be a 1. It's not. It's currently a negative 2, so we need to pull the negative 2 out, leaving us with the x squared. And then now you have to think, understand how distributing works. This negative 2 times x squared will give us this. The negative 2 times what will give us this. So whatever you think I could multiply by a negative 2 and get a negative 12, that's what we're going to put next in that spot. So, what do you think, Cam?
Wouldn't it be a positive 6?
Good. That has to change to a positive sign, and then it is a 6x. You can check yourself very quickly, right? Negative 2 times x will give us the negative 2x squared. The negative 2 multiplied by 6 will give us a negative 12. That's how we know if we did that correctly. And then we're just going to make a perfect square trinomial out of this. Actually, I think we just did that one, right? We added a 9 to this. Divide those 6 by 2. That gives you 3. Those would get multiplied by each other to get a 9. So what we've done now is we really added a 9 here. But we've added not only 9, we've added a negative 2 times a 9. So remember what we've been doing this whole time. On the back side, we've been subtracting away whatever we added to that problem. Understand now what we've added to this problem. Haven't we added a negative 18? A negative 2 times a 9 is a negative 18. So we're going to subtract away a negative 18. Any questions on that? All right, so now when we go to simplify this and to write this in our vertex form so that we can now answer some questions on it, this would be x plus, this would have been a 3 and a 3. We see how this is a double negative, so we actually end up adding these, and we should get a positive 23. Okay? So understand, when I did the negative 2 times 9, that's really a negative 18. So what we ultimately do back here is the opposite. We need to add 18, okay? Or subtract the negative 18 if it's easier to think of it that way, okay? All right, 18. Let's do number 18. Do one more together, and then I'm going to turn you loose on number 19. Take your negative 3x squared, the negative 36x. We're going to make perfect squares out of those. Really bad, 36 now that I look it up on the board. There you go. The number that needs to be the 1 is currently a negative 3, so negative 3 is what we're going to pull out, leaving us with an x squared. And then now you are thinking a negative 3 multiplied by what would give us a negative 36. And whatever that answer to the question is, that's what you're putting next. So negative 3 multiplied by what gives us a negative 36. It would have to be a positive 12x. Negative 3 times 12 gives us a negative 36. Close it, and then still have our plus 1 there. Okay, complete this square. So that just means we take the 12, we would split it evenly if we did the square. 6 of them would go in one corner, 6 go in the other. The bottom right-hand corner is in 6 times 6. So we would be adding 36 to make this a perfect square. Oops. But what we've been saying, we don't just have one 36. We have 3 36s. Was that 108? I think so. 3 times 36 is 108. But the fact that it's a negative 3 means we really have a negative 108. So we would then have to subtract, like we've been doing all along. We'd have to subtract the negative 108. Which really, in essence, means we're going to be adding the 108. So we get our negative 3, x plus a 6 squared, plus 109. All right, here's what I want you to now do, because here's what we eventually want to be able to get to now, is if I give you this equation and start asking what's our vertex form, what's vertex, axis of symmetry, do we have a maximum, do we have a minimum, what's our domain, what's our range? In order to do that, we need to get this guy into vertex form first, and then we can start answering all these questions that we've already quizzed on. So now, try number 19. It's just a 1 now, but it has to, maybe we, actually try 22. Do that one for me. That one's similar to what we've been doing. Jump to 22. And see if we can get through that one. Give you a minute or two. See what we get. Okay, a little check at home. If you want to see if you did it right, we'll go through it here in a minute. If you did, pat yourself on the back. If not, then make sure we're paying attention to see where things went wrong. This should be your answer. So if you got through that one good, and this is what you ended up with, we're there, you're getting it. Okay, so that's good. If you didn't, pay attention, kind of see where things went astray. And then next time, hopefully we don't make whatever that mistake might have been. So all we did again, we ignore the constant. We're going to make a perfect square out of the first two terms. We talked about how this has to be a 1. Right now it's not, so we're going to get rid of that. Pull that out as a negative 3, leaving us with the x squared. And then you're thinking negative 3 multiplied by what would give me a negative 6? That had to have been a positive 2. So the negative 3 times x squared gives us this. The negative 3 times a positive 2 would give us this. That's what we're going to make our perfect square trinomial out of. So you would then take these two x's, you would have split them up evenly between two different corners. That leaves you with a 1. And then you would have done 1 times a 1, which should just be a 1. So what we've just found is each square has a 1, so that's what we've added. But there would have been 3 of them, 3 times the 1. But it's not just 3 of them, it would be a negative 3 of them. So we subtract away the negative 3 that we added, which is really just adding a 3, so that's where my 7 is going to come from. And then this here, as a perfect square, is just x plus 1 quantity squared. Okay? We're getting this now a little bit, hopefully. All right. From there, this hopefully we're all good now. We can say our vertex is a negative 1, 7. Our axis of symmetry, we can say now is x equals a negative 1. We won't do it now, but I can now start asking you domain range questions. Do we have a max or min? All these things now we can start dealing with. Even though we start in standard form with these, once we put it into vertex form, now we can answer all of these questions. Okay? All right, then I want to do 2 more before we get out of here. I want to do one with a negative 1 in front of it. So let's hop back to number 19. And nothing difficult, any more difficult anyway. When I've been saying we want a 1 in front of the x squared, specifically it needs to be a positive 1. So right now, there is a negative 1 in front of this. So when we split this up to create a perfect square, a negative 1 is not good enough. It needs to be a positive 1. So we're going to pull the negative 1 out. So just like we've been doing in that next step, take the negative 1 out, leaving us with an x squared. And then again, you're thinking to yourself, for the next term, negative 1 times what would give you a negative 10? So a negative 1 multiplied by a positive 10 would give you the negative 10 that we started with. From there, I mean, now it's kind of the same thing over and over and over again. To make this a perfect square, you divide the 10 by 2, because you would have put 5 in one corner, 5 in the other. And then 5 times 5 would have given us 25. So we've added a 25. Now in this case, we've only added one of them. So it truly is just 1 25, except it would be a negative 25. So on the back side, we subtract away a negative 25, which really just means we're adding a 25. So our answer should have a negative 1. And then this would have been an x plus a 5 times an x plus a 5. And then on the back end, we just get a negative 3. All right. So now your homework is to do all of these. Now we should have a good 10 to 12 of these done for you. Okay, so hopefully the ones that I've left you now we're going to be able to go through and do. I said I wanted to do 2 more. The vast majority of your homework is going to be these types that we've now spent 3 days on. So hopefully you can look at these, you can get through these, and have some success. The last type, though, I want to make sure you see, just so you can understand this, is the last 4. So go to 23 through 26. We've just spent the last 3 days going from standard form into standard form into vertex form. The last couple are just making sure, well, if we do give you vertex form, so now this is the nice form, this is generally what we want. But if we do give you this, could you put this into standard form? Can we kind of go the opposite of what we've been doing? All right, so this would just mean now we want to kind of undo all of this. X plus 3 squared is really just an x plus 3 times an x plus a 3. So we want to multiply that out. So do your x times an x, and well, yeah, let's do it this way. And then the x times the 3 is a 3x. 3x times 3x, 3 times x is 3x, and then the 3 times the 3 is a 9. And then we still have minus 9 at the end. What we then end up with is x squared plus 6x. Notice how we have a positive 9 here. Take away a 9 right there. These guys are going to cancel each other out. This is our answer. Okay. Let's do one more since we have a little bit of time, and then the rest of the time. If you wanted to get started, you could. So this is really x plus 4 times x plus 4, and then plus your 3. A couple different routes we could take in doing this. I'm going to go this route. I'm going to first do what we just did in that previous problem. Take the x plus 4 and multiply it by the x plus 4, just like we did with these guys over here. So the 2 I'm going to ignore. I'm going to drop it down. And we're going to do x times x and x times a 4. Then you're going to take your 4, multiply, that's a 4x. And then the 4 times the 4 is a 16. Close that, and then we have the 3 still kind of hanging out at the end. Notice how you have like terms in there. So I am in the next step. I'm going to put these guys together. We have 8 of them. So we just put them together. All right, now that the inside is simplified, now I'm going to go ahead and distribute this too. So just take your 2, multiply it by everything in front, or behind it, I should say. And then finally, we do our little plus 3 right there. See if I can squeeze this in. Y equals 2x squared plus 16x plus, and then these end up being our like terms right here, 35. Now, if you're really good, okay, if you're really understanding this well, let's go back to this guy. And maybe some of you are, and you're saying Mr. Pena's making this way too hard and way too much work. We've done enough of these. Wouldn't we be able to kind of think what that would give us right away? If we think of our square or area model, if we have an x plus 3 here and an x plus 3 here, wouldn't we hopefully know at this point that we're going to get an x squared? Wouldn't we have to have 3x's here, 3x's here, so that has to produce a 6x? And wouldn't we know that this has to be a 9 right there? So wouldn't this here have to give us this squared? And we can go right away to x squared plus 6x plus 9. And then take the 9 away at the end. And we're going to get this answer very quickly. Okay? If we look at the other one, same thing. If you don't want to do all this work, honestly, I think the work is the safer part. My juniors and seniors that I get in calc screw this up all the time trying to square a binomial. But if you're really, really good, don't we know if I have x plus 4 squared, that I have an x and a 4 here and an x and a 4 here? So I'm going to get an x squared out of that. So I really could just do 2 times x squared. I have 4x's here, 4x's here. So I know I have 8x's overall. And then doesn't this give us a 16 right off the bat? And then we can start distribute your 2, combine your like terms, okay, all that good stuff. Okay, so it's up to you. If you think you can do this very quickly and go right to these, feel free. Otherwise, write them out and just do the foiling, do the distributing. Okay? All right, so with that, we are mercifully done with this in class for the last 3 days. So your homework now is, what was that, page 23. So this page here, you're going to do 1 through 26. You should have at least half of those done already. Like I showed you on Canvas, you have the place to post that or upload that. You can do that by Monday nights. If you have any questions, we can talk about it a little bit on Monday. The next section is 2.7. 2.7 is a review. It's a practice understanding task. Practice just means it's more of the same, more of us practicing. So Monday should also be a day to just kind of put it all together. Tuesday then is going to be the quiz over all this. Okay? Okay, if you have any questions, feel free to hang out. We're inside of 3 minutes though, so I'll let you go and see you guys next week. All right, have a good weekend.